Hello students, welcome to today's session of light. In our previous sessions, we have learned about refraction, Snell's law of refraction, and how the Snell's law is applicable to normal incidents, whether it is valid or not valid. All these points we have studied in our previous sessions. If you haven't watched the video, please watch our backup videos. In today's session, we are going to learn about refractive index, its formula, significance and definitions. Students are often confused with refractive index. What is refractive index? What does it mean in case of light? What does it do with light? What is its formula? What is its significance? And how can we define the refractive index of one medium with respect to another medium? Actually, they get confused in this case. So let's focus on refractive index, an important topic in light. Let's focus on its formula first, and then we will go to definition. First, it's very important to understand the formula. Once you understand the formula, it's easy to define refractive index, and it's easy to say its physical significance. How many types of refractive indices are there? So refractive index is denoted by a letter mu, Greek letter mu. Some book it is written as n. It is broadly categorized as relative refractive index and absolute refractive index. First, we will learn about relative refractive index. From the name itself, relative refractive index means relative. We are comparing. Actually, we are taking the ratio or doing the comparison of two quantities here. All right. So the relative refractive index. The first relative refractive index was given by Snell's law. So in Snell's law, Wilbrod Snell suggested that refractive index of a medium mu is equal to sine of angle of incidence to sine of angle of refraction. All right, sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium. So I can write, in that case we write refractive index of the second medium with respect to first medium. All right, the relative refractive index of second medium with respect to first medium. Sine of angle of incidence in the first medium, sine of angle of refraction in the second medium. Please remember this. So like this, a ray of light traveling in one medium number 1. So normal, it is getting refracted. This is the angle of incidence and this is the angle of refraction. What did Snell's do here? He took out sine of angle of incidence and sine of angle of refraction. He found out the ratio and he got it as a constant, that is mu, refractive index of the medium, that we call it as light bending capacity of the medium. Refractive index is nothing but it is the light bending capacity of the medium. All right. So the first relative refractive index in terms of angle of incidence and angle of refraction is given by Wilbrod Snell. The second one, the second type of relative refractive index is that we compare the relative or refractive indices of one medium with respect to another medium. Very simple. We compare the refractive index of one medium with respect to another medium. So in that case, how can I write the refractive index? Students get confused. Refractive index of the second medium with respect to the first medium. Okay. Refractive index of the second medium with respect to the first medium. So I can write it as refractive index, as you read, refractive index of the second medium with respect to first medium. So I can write refractive index of second medium with respect to refractive index of the first medium. Very simple. All right. So how can I write then refractive index of the first medium with respect to second medium? How can you write? Very simple. Refractive index of the first medium with respect to second medium. Refractive index of first medium, as you read the statement, the answer lies in that statement, mu 1 divided by mu 2. Okay, is it clear to you? Yes. So for example, so remember this formula. Okay, in terms of refractive indices of two medium, we are just doing a comparison. For example, refractive index of glass with respect to air is 1.5. All right. Then what is the refractive index of air with respect to glass? How do you write it? So very simple. Refractive index of air with respect to glass. See from the statement, refractive index of the second medium with respect to the first medium. So refractive index of the air. First, what is the refractive index in air? 1. Okay. Refractive index of glass 1.5. 1 divided by 1.5 is 0.67. 0.67. So refractive index is a pure ratio. It has no unit. So you will get it as a pure ratio. It is a dimensionless, unitless quantity. All right. So what is the meaning of 0.67 in this context? What does it mean? Here the light is traveling from glass to air. Okay, the light is traveling from glass to air. Here the light is traveling from air to glass. So what is the meaning of this statement? What is the meaning? 1.5. It means that when a ray of light traveling from air to glass, the speed of light in air is 1.5 times greater than the speed of light in glass. Okay, what does it mean? The speed of light in air is 1.5 times greater than the speed of light in glass, or the speed of light in glass is 1.5 times lesser than the speed of light in air, conversely reading. All right, so that is the meaning of the statement refractive index is equal to 1.5. All right, okay. Now another example to make it more clear, let us choose one more example. Refractive index of water is given as 4/3. All right, refractive index of glass is given as 3/2. Clear? So what is the refractive index of then? What is the refractive index of glass with respect to water? This is our question. So relate it with this context. How do you write it? Refractive index of glass with respect to water. Very simple. Refractive index of glass, what is that? I can write refractive index of glass divided by refractive index of water. As you read the statement, put it in the formula. Very simple as that. That's equal to, what is the refractive index of glass? 3/2 divided by refractive index of water 4/3. That's equal to 3/2 into 3/4. That is equal to 9/8. You are getting it as 9/8. That is equal to 1.125. It is a unitless quantity. All right. Is it clear to you? Fine. This is the second one, relative refractive indices of one medium with respect to another medium. The third is we define refractive index in terms of speed of light in one medium with respect to the speed of light in another medium. So we compare the speeds of light. So I can write here the third relative refractive index we define in terms of speed of light. All right, speed of light. Very simple. In terms of speed of light. Okay, in terms of speed of light. So how do you write the refractive index of medium 2 with respect to medium 1, medium 2 with respect to medium 1? In this case, remember that just write the speed of light in medium 1 v1 divided by speed of light in medium 2. Very easy to remember. Or remember the first one, mu 2 refractive index of second medium with respect to first medium, mu 2 divided by mu 1. Here it will be just a reverse of that, reciprocal of that, v1 divided by v2. If you remember the first one, second one easily can be correlated, can be figured out. So the refractive index of second medium with respect to first medium, the speed of light in first medium divided by speed of light in second medium. Okay, then how do you write refractive index of medium 1 with respect to 2? How do you write? So very simple, speed of light in medium 2 divided by speed of light in medium 1. Okay, so this way the refractive indices, relative refractive indices can be defined or can be related in terms of speed of light in medium 1 and 2. Very simple. Okay, so for example, the speed of light, I take it as 3 into c 10 to the power 8 meter per second. that is speed of light. Okay, I denote it with a letter C. And the speed of light in glass is 2 into 10 to the power 8 meter per second. Okay, so what is refractive index of glass with respect to air? Refractive index of glass with respect to air. What is it? So write it. Refractive index of glass with respect to air. So write the speed of light in air. Speed of light in air divided by speed of light in glass. I write it as Vg. Speed of light in glass. That is equal to speed of light in air 3 into 10 to the power 8 meter per second divided by speed of light in glass is 2 into 10 to the power 8 meter per second. Get cancelled. We are getting it as 1.5. That is the refractive index of glass with respect to air. Okay, all right. So these are the three types of relative refractive indices in terms of angle of incidence and angle of refraction, in terms of two refractive indices of two medium, or in terms of speeds of light. Now coming back to the absolute refractive index. Absolute means we compare the speed of light with the maximum value or the ultimate value. Ultimate, the maximum value. Okay, you know that the speed of light is maximum in vacuum, that is we write 3 into 10 to the power 8 meter per second. This is the maximum value. So of course we compare with the speed of light in vacuum. So I can write refractive index of medium 2 with respect to 1. I can write the speed of light in one medium 1 with respect to speed of light in medium 2. Or I can write refractive and absolute refractive index of glass with respect to air. I can write speed of light in air divided by speed of light in glass. So the absolute refractive index, we are comparing actually with the refractive index of the air, that is the air or vacuum, that is where the light has the maximum speed, the ultimate value. Alright, so in absolute refractive index, what we are doing, we are comparing the refractive index of any substance or any medium with respect to air. Please remember it. So that we call it as absolute refractive index. So when we write it, just write mu glass. It is understood that refractive index of the glass is compared with air. We don't need of writing air here. So as 1.5. That is absolute refractive index. Alright. Then if I say refractive index of how do you write refractive index of glass with respect to water? How do you write it? How do you write refractive index of glass with respect to water? Refractive index of glass with respect to water in terms of this formula. So how do you write? Very simple. Speed of light in water divided by speed of light in glass. As simple as that. Refractive index of glass with respect to water in terms of speed, right? How do you write? So just remember this, the superscript, speed of light in water, the subscript divided by speed of light in glass. Alright, okay, then how do you write speed of light, refractive index of water with respect to glass? Very simple. How do you write refractive index of water with respect to glass in terms of speed of light? Very simple. So the refractive index of, that is speed of light in glass divided by speed of light in water. We get it. As simple as that. Very simply. See, as you read the formula, just place it here. Okay. So in this way, the absolute refractive index can be taken out, can be calculated. So remember, relative refractive indices 3 ways and one absolute refractive index in terms of speed of light. If you observe this formula, we know that refractive index of glass in terms of speed of light is speed of light in vacuum divided by speed of light in given medium. Okay, this is the formula. So look at this formula. The speed of light in any medium is, of course, will be lesser than the speed of light in vacuum. So the refractive index of the any medium will be greater than 1. So refractive index of any medium will be greater than 1. Why? The refractive index of any medium will be greater than 1. That is because the speed of light in any medium will be lesser than the speed of light in vacuum or in air. In air or vacuum, light has the maximum speed. When enters into any other transparent medium, its speed decreases. So I can write the refractive index of any other medium other than air or vacuum is always greater than 1. Why? What is the reason? Because speed of light in vacuum or air is maximum. So therefore I can write the refractive, obviously from this formula I can write refractive index of air is 1. Okay, so no medium, no material, no substance has the refractive index lesser than 1. So air has the refractive index 1. So any other medium will have refractive index greater than 1. Is it clear to you? I hope the points discussed, it is clear, crystal clear. Okay, thank you. So we got the formula of refractive index in terms of angle of incidence in medium 1 and angle of incidence in medium 2. Sin I by sin R is equal to refractive index of the second medium with respect to the first medium in terms of angle. And in terms of relative refractive index of two medium, like refractive index of the medium 2 with respect to refractive index of the medium 1. And in terms of speed of light, refractive index of medium 2 with respect to 1, speed of light in medium 1 divided by speed of light in medium 2. So we will go to the definition part. So the formula is clear, its significance, its meaning is clear. So what is it? If you understand the formula, you can define it. So refractive index of the second medium with respect to first medium is defined as sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium. Alright. So the refractive index of second medium with respect to first medium is the ratio of sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium. Alright. So in second case, how do you define the refractive index? Refractive index of the second medium with respect to the first medium, the refractive index of second medium divided by refractive index of first medium. As you read, the formula lies as you read. Okay. Now, in terms of speed of light, how do you define the refractive index? Refractive index of the second medium with respect to the first medium. That is the speed of light in first medium divided by speed of light in second medium. Okay, as simple as that. Next, the absolute refractive index, we compare the refractive index of any medium with respect to air. So in that case, the speed of light in air divided by speed of light in a given medium. So I am generalizing the case. Refractive index of any medium with respect to air is the speed of light in air or vacuum divided by speed of light in medium. M stands for medium. Alright. So I can write here refractive index of second medium with respect to first medium, mu2 by mu1 is equal to v1 by v2. Very important expression. Alright. I hope today's class was very helpful to you. Please do comment in your comment session. Send your feedback so that we can make any modifications, corrections as per your feedback. Thank you very much.